want to be a chemist because ever since I think it was in the 4th grade, I saw dry ice during the summer camp, and it just messed with me because I couldn't understand how ice could emit gas.
How much we don't know and how much more we can figure out even by asking the simplest questions.
I feel like the research experience not only promotes independent thinking, but also encourages teamwork.
What surprised me most about research was how different it is from the academic setting within chemistry. It requires actual thinking, in my opinion, and asking new questions, as opposed to just digesting information and then regurgitating it on a test.
He's always there for his students. He is always there to support you and give advice, and he also encourages independent research.
We use computers instead of doing what is popularly called wet chemistry because computers allow us to do things that experimentalists have difficulties doing, for example, studying systems at low temperatures or studying certain extreme conditions. So how do computers do the work that we want them to do? Think of Google Maps, for example. You can find an origin and a destination, and Google Maps will determine for you what the fastest route is to that destination. In a similar way, computers can be used in chemistry to try to determine how, when two molecules are reacting, they will arrange themselves to achieve the outcome that they want to achieve. This reaction, for example, shows monovalent boron coming towards a substituted silicon center. And the boron bonds to the silicon first, and initially we think that's it. But then a hydrogen jumps from the silicon onto the boron, so that now we end up with a silicon-boron bond that did not exist before. So this was a big surprise for us. We expected that it would have just a weak coordinate covalent bond to silicon, but instead we got this transfer to form an entirely new compound, which provides us with a lot of promise for developing new compounds. We're interested, for example, in materials that might have new and interesting physical properties. We're interested as well in catalysis, predicting new catalysts that may be used in various applications in chemistry, for example, in polymerization. And we're interested too in understanding bonding interactions across the periodic table that have implications for how new compounds can be formed and stabilized. It's a great privilege to me to work with undergraduates, to be able to see young minds emerge, to think in deep ways about complicated problems, and to become partners with me in solving questions that are of interest on the frontiers of science in my field.